Hello everyone, welcome to today's recording on Level 2 Organic Chemistry, the 2018 examination paper. So as always, one question per video, and let's get started. So a lot of people have been requesting certain examination papers, and just before we get into this one, I am planning to finish, if not all of the 2018 examinations, so that's for Level 2, Level 3 Chemistry, as well as Level 1 Science. It's all coming, but it takes me time to obviously record them, and once I finish the 2018s, and I will quite a few people have suggested do some 2017 exams, and that should take us all the way to the examinations themselves. Okay, so that's the plan. So let's get started with today's one. So organic chemistry, first question, looking at naming. So this is complete the following table. So as always, 1, 2, 3, 4, 5 carbons. You have a double bond in the first carbon, so this is pent, 1 in. You always keep the double bond to the lowest bonded carbon, lowest number carbon, hence that's pent 20. All right, next one. This is an alcohol group. You have 1, 2, 3, 4 carbons in the longest chain, so this is butane-2-ol. And then excuse me, on the third carbon you have a methyl group, so this is 3-methyl butane-2-ol. Okay, next one, 2-hydroxypropanoic acid. Going backwards is always easier. Hypopropanoic acid, so 1, 2, 3, this is propanoic acid. 2-hydroxy means on the second carbon, this is carbon number 1, this is carbon number 2. On the second carbon you have a hydroxy group, which is OH, and then you just finish everything else by completing the number bonds by adding hydrogens. Alright, should be quite straightforward. Next one, draw structural formula for primary, secondary, tertiary haloalkanes, chloralkane molecules that has a molecular formula of C4H9Cl. So it's quite easy. I always go with something like this. As you can see, I don't do the hydrogens first because the hydrogens just fillers, and then this is a primary chloralkane because the Cl is bonding to a carbon, which is bonding to one other carbon, so this carbon is only bonded to one other carbon directly, and then I can just finish it up by adding all the hydrogens in, and that should add up to 9 hydrogens as well. So secondary, it just means you put the Cl bonding to a carbon, which is bonding to 2 other carbons, and then just put that the H's in accordingly. Make sure every carbon has 4 bonds. Tertiary is when you have a Cl bonding to a carbon, which is bonding to 3 carbons. So that's CH3, CH3, CH3. Every single carbon has 4 bonds. And we answered this question. Next one. Perspex is a polymer, use blah 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 blah. So this is a structure. In the box, draw 3 repeating units. So when we want to draw 3 repeating units, I normally again encourage you, if you're not really good at drawing these, this is what you can do. Do it like this first. Put the double bond in the middle, and then do 1 up, 1 down, copy paste. Just do 1 up, 1 down, copy paste. So you just, when they say repeating units, you're literally just drawing the same thing 3 times. Okay, so that's polymerization for you. Now we're not done here. I'm going to borrow the rubber. So these are all alkenes, and when the alkenes connect together, they undergo addition reaction. So I deleted the double bond, and then they are going to single bond and connect to everything. And just make sure you do this, and that's all the molecules done. All right, next one. Justify whether or not the monomer used to is a geometric isomer. So they're looking at this thing, and they're asking you, is that a geometric isomer? The answer is no. Why is that? The two conditions for anything to have a geometric isomer. First of all, you need to have a carbon-carbon double bond because that limits the free rotation around the double bond and around the carbons. Number two, the two groups of carbon bonding to each of the two groups of atoms bonding to each carbon in the double bond must be different. So if I highlight these two hydrogens, they are the same, so this doesn't have geometric isomers. Okay, so this is your typical excellence question for level 2 chemistry. So cannot have geometric isomer, must have a double bond, prevents rotation, the monomer has this, but however, the carbon of the double bond must have two different atoms or groups of atoms attached to them. So if the other carbon has two hydrogen atoms, therefore you can't have cis and trans isomers. Okay, very straightforward. It's the same old question every single year. You just that's why, you know, grinding a couple of years of examination and watching my videos should help you understand how the process works, and then you wouldn't need to look at you wouldn't need to watch this unless you're really stuck with the question. Okay, next one. When butane react with butanese react to form bromobutane, two organic products are produced. So let's draw them first. So first thing first, butane. This is butane. Oops, CH2. And when reacted to form C4H9Br, the only possibility for that to happen is that you add HBr. And when you do that, is that you make major minor products. So what's going to happen is you have two choices. I'm going to draw them like this. I'm just going to copy paste everything the way I've done for my, using the same logic as your monomers. Can you see all I did is that I changed the double bond into two single bonds. Okay, now when you're adding the HBr in, that means the H and Br can be added to the carbons differently. So one goes on the left, one goes on the right, and then vice versa. Which one's major, which one's minor? And this is where it's quite helpful to look at these. Can you see that carbon? The carbon I just highlighted has only one hydrogen bond to it right now. The carbon I just highlighted just now has two hydrogens bonded to it. So the carbon on the right hand side is a richer carbon in terms of hydrogens. So it is more likely for that carbon to pick up another hydrogen. So this is major, and then this is minor. Please don't explain this just saying major, rich gets richer. That's not enough to give you the full points. So the reagents required is going to be HBr. The type of reaction is addition reaction because you're breaking the double bond to add something across. And why is it a mixture? Because you have an asymmetric alkene which can have geometric isomers. Okay, so you don't need to say Markovnikov's rule or anything like that. You just need to mention this. So HBr is a reagent, double bond, double breaks in an addition reaction. So what happens, because the thing is asymmetric, the thing's asymmetric, so the two possible combinations, the carbon with the most hydrogen will gain another hydrogens. That means this is a major product and the other one is a minor product. Okay, very easy excellence question, I hope. It's the same every single year pretty much. Okay, so hopefully this video has been helpful to you, and we'll do question 2 for the next recording. All right, I'll see you guys next time. Bye bye.